Hey, what's up everyone? This is Josh. Welcome back to our video tutorial series on iOS design patterns. In this video, you'll learn about the MVC-N pattern. Let's quickly review Model View Controller, or MVC for short. MVC separates objects into three types: models, views, and controllers. But wait! Is it really this simple? Well, what about handling taps? Or loading data from a remote server? Or transforming model data to be set on views? Aha! These three types actually overlap. Well, where does the overlapping code actually go? Handling taps is a very controller thingy action to do, right? Well, what about loading data? Also a controller thing? Or transforming model data onto views? Well, controllers do that too, right? Well, before you know it, you've created a couple thousand line train wreck of a view controller. This is what's known as the massive view controller problem. Fortunately, there's another pattern that can help. Introducing the Model View Controller networking pattern. This is even better than MVC because it separates objects into 4 types. 4 is better than 3, right? Yes it is. Instead of duplicating networking logic, which the demo project is currently guilty of doing, MVC-N creates a network client to handle networking logic. Network clients often make network requests, serialize response data into project-specific models, or domain models as they're called in developer jargon, and return models to a view controller via a closure callback. In the demo, you'll be doing just that. We'll start by creating a network client and pulling existing networking logic into it. Then, we'll refactor existing view controllers to use it.
I currently have the RW Clean app running in the iPhone simulator. After tapping on Get Started, the Cleaning Services Table View controller is shown. This has 2 options, one for home services and another for business services. Let's select the first. This presents the Home Products View controller. This controller makes a network request to get all of the home products. Now this load happens quickly, so you likely didn't notice it. If you pull down to refresh, you'll see a refresh control while the networking call is being made. If we go back and then select the business services, this presents the business products view controller. This likewise makes a network request to get the business products. Now, let's go ahead and jump over to the code and see how these look. We'll go to the Cleaning Services and then Controllers subgroup, and you'll see that there is a Business Products View Controller and Home Products View Controller. Each of these has a Load Products method, which is actually nearly identical. The only difference is that the Home Products View Controller accesses the Home endpoint, and the Business Products View controller, it uses the Business endpoint. The error handling logic and also the product parsing logic is exactly the same. This sort of duplication is called a code smell, which is an indicator that something may be wrong. In this case, we want to use the Model View Controller networking design pattern and create a network client to handle all of the networking calls. This will then be used by both controllers, which will eliminate the code duplication. To do this, however, we first need to create a new group for networking. In addition to the networking group, I've also created subgroups for extensions and models. We'll need these soon. Next, you need to go to wherever you downloaded the files for this video. In addition to this project, you'll also find that there's a resources directory. I've got mine right down here. Here you'll find several files that are related to networking, but they aren't central to the MVC-N pattern. So in lieu of actually typing out all of these, I provided them to you so you can drag and drop them into the project. First, you want to move the int plus HTTP status code and the UI image view plus URL into the extensions subgroup. Make sure copy items if needed is checked. Next, move network error into the models. And lastly, network client directly into the networking group. Let's quickly take a look at each of these files. Int plus HTTP status code simply provides a convenience property to determine whether or not the int value represents a success HTTP status code in the range of 200 to less than 300. UI image view plus URL provides a convenience method for setting an image on an image view given a URL. You can check out this implementation here if you're curious, but the details really aren't too important for the rest of this demo. It'll simply be used by other files later on in the project. Network error is a simple enum that conforms to the error protocol. This allows us to convert an HTTP status code error into a simple model that can be used by the rest of the app. What we're most interested in is actually this network client. This will be where we'll move the existing networking logic. This currently has just a single class instance property for the shared instance. This reads from a server environments plist and gets out the service URL. This is in lieu of actually hard coding the URL directly into this class. It's a little bit nicer, but really it comes down to kind of a preference. If it's always going to change, you could put it here, but whichever you want to do. Now, the shared instance, it's mainly just for ease of injection purposes. That is, it's easy to get a network client simply by accessing its shared static property. This is also called a singleton instance. Now, there's many opinions about singletons, both for and against them, but for a network client that's meant to only have one instance, it's arguably okay to do this. Next, we need to actually move the duplicated network logic into this network client. We'll start by creating a new method to get the products. This takes in a type, which is a product type. And under the hood here, this is just simply an enum that we'll use to create the desired business or home endpoints here. And in order to ensure that the passed in success and failures are called on the main thread, this isn't actually guaranteed by URL session tasks. What we'll do is simply create wrappers for the success and failure here that just dispatch to the main thread and call the passed in closures. Now, the network client doesn't actually care what's done with the resulting product array, but it just wants to vend it to whatever the passed in success closure is. Of course, if the network task is actually successful, or vend the error if the network task has a failure via the failure closure. So we'll update this method to do just that. Okay, so let's quickly go through this here. Essentially, we first try to cast the HTTP response, which we expect to be an HTTP URL response, and then verify that the HTTP response has a success status code. And then we expect the JSON to be in a certain format. So the data we expect to actually be JSON, and the JSON is actually a JSON array. So string for all of the keys, and then any values, as it could have numbers or strings. If any of this isn't true, we will call the failures. If there is actually an error object as part of this completion handler, we will try to create a network error using it. Otherwise, we will use the response to create this network error. There's just simple initializers that accept either of these. However, we hope that the JSON actually is correct and that there aren't any errors, obviously. So in that case, we can simply call a convenience class method on product, which accepts a JSON array, and call the success closure. Tasks aren't automatically started, so we have to ensure that we call task.resume at the end. Okay, with this method out of the way here, we lastly need to actually update the business products view controller and home products view controller to use this network client and this new method. So let's go over to the business products view controller and scroll up here. First, we get the network client shared instance, and then next, we'll update load products to use it. Okay, so we also need to update home products view controller as well. To do this, we're actually just going to copy this load products method, switch over to home products view controller. We first need to add an instance property. And then we'll go down and update that load products. And the only thing we need to change is instead of business, we want home products. Let's go ahead and build and run. And everything should actually work as it previously did. Awesome, so home looks good. And business does too.
The app is doing much better. However, there's one more view controller that needs to be refactored to use that networking client. This is your job for the challenge. Pulling out networking is a great start to combating the massive view controller problem, but it doesn't solve the issue entirely. Stay tuned for the next video, where you'll learn about another pattern that also helps. Thanks for watching, and I'll see you next time.